All right, let's have this. Let's say we have carbon bonded to carbon, 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 bonded to carbon. Because I still have to give you what we call isomers, isomerism. I'm going to have to give you that. Don't worry. I'm going to give you what isomers are. And then I can put another one here. Another one there. And now we can place the hydrogen all over. We can place hydrogens all over here. You can put hydrogens all over. Other ones, I'm gonna make them in a different color so that it's clear to you where hydrogens are. Where hydrogens are. I think you can see what we are doing. Am I right? All right. So now my question is, at this moment, are you able to pick which chain is the longest one? I'm gonna give you something to identify by the location. Let me do this to help you see things clearly. I'm gonna shift this one down, and I'm just gonna make a straight line longer so that things are clear. Yeah, there we go. Now with the green, I'm gonna call this point here A. I'm gonna call this one B, the end points, and this one C. So this means if you guys are going to pick up the longest chain, there are 3 options I can see. 4, I see 4 options. It's either you're gonna go this route, A to B, can you see that? Or you will go like this, the one that looked like a 7. Do you also see that one? Or you're gonna go like that. Those are the 3 options. I don't see any other option. So it's either you're gonna start from A to B, or A to C, or B and C, looking for the longest chain, the one that has many carbons. I don't know which one. You can tell me. Is it A to B, B to C, or A to C? Yeah, so which one will you choose as the longest? Yeah, but which one are you going to choose? Will there be any different if I were to choose B to C, BC? Not different. All right, so far so good. The point I'm making is that since this one is 7, and also that one is 7, it does not matter which one you choose. The answer will be the same even if you choose that one or you choose that one. To you, this look like a methyl to you because in your head you chose that one. That's why I was saying, why do you say it's a methyl? But for somebody who would have chosen this, to him a methyl will be that one. Can you see that? Yeah, so the point I'm trying to say is, if there are different route or paths, ways, where you find the number of carbons are actually equal, it does not matter which one you choose. The answer will be the same, just like anybody else. All right. Because now when I do this, there might be another one. I could have done it this way also. Let me just show you a little bit. I could have branched it here. And we go carbon, we go carbon, we go carbon. Whereby you have no choice. You'll have to go around like zinyoga nyog. There's no straight line. Even straight line. Yeah. So I'm trying to train your mind not to think necessarily straight line. It can be around the bend. Yeah. All right. So let's go back here. So fine. We can choose the straight line in this case. So if we choose a straight line, I would say always put it in the box or highlight it, including the hydrogen that goes with those carbons. So we can go this route. That's step number one. We have identified the longest carbon to carbon to carbon to carbon chain, but we're keeping in mind it is not always necessarily a straight line. We good, right? Now everything that is outside the box, it's going to be what we call an alkyl group. There is what they call it alkyl, alkyl. Let's go back here. Remember this one, it was alkane, A-N-E, meaning the name ends with A-N-E. These ones were alkene, ending with E-N-E. The other one were alkyne, N for nothing. They end up with Y-N-E. But the groups that are outside, the branches, they are Y-L, alkyl. Their name will end up with the Y-L. If it's meth, it will be methyl. Methyl. If it's eth, ethyl, because they are outside the box. Everything outside the box ends with the YL. All right, so normally I say, all right, fine. Once we had step number one, choose the longest chain. Step number two, that longest chain that is in the box, you can number it from alphabet A from the left-hand side, like saying carbon 1, carbon 2, 3, 4, 5, 6, 7, all the way to alphabet B to the right. You can number from left to right. But you can also number from right, from B, all to the left to A. So now, that's where step two comes in. How do we choose the numbering? It matters, I'm saying it now. It matters in this case, whether you're moving A to B or B to A. The numbering matters. How do you choose the numbering? We can see it matters. We are numbering. Let's go back. Remember here, it matters if there's a functional group. You number in such a way, you must be aware or mind the functional group. If the functional group is not there, check if there's a triple bond. If the triple bond is there, you number in such a way in your mind you are thinking of the triple bond. If functional and triple are not there, you should have a double bond. You number in such a way you are aware of minding the double bond. If they are not double or triple, it's obvious it's only single bond, but you number and be aware of the branches. Can you see now? So I'm saying in the presence of the functional group is the boss, is the king. If functional group is absent, the king will be triple bond. If the triple bond and functional are not there, the king will be double bond. If functional, triple, double bonds are not there, the one that rules is the branches. So you number in a way to be careful about the branches. Okay, can you see? I didn't put single here because I know where there's branches, it's basically you're having singles. So that's why you were saying, don't mind, because you were thinking single bond. That's why I never included them. Yeah, so we are not looking at the single bond. We must be careful of the branches. So that's why I wrote this thing to help you which one you give the first preference. Because sometimes you might have triple bond and a functional group. You number checking the functional group. What if all of them were there? You've got a branch, you've got a double bond, you've got a triple bond and a functional group. How will you number that? Checking that the functional group, you give it first preference. I'm not mentioning some other words because I'm having a question here where I want you to answer. So how are we going to number this? Yeah, I can see the position of the branches is down. It's under the box. So even here, watch now. Even here, the position will still be down. It's down. Down, 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 down. What do you mean about the position of the... Yeah, say, I want you to say something more. Mm-hmm. Okay. Yeah, you number the longest chain such that the branches or the branch is assigned or given the smaller number. Yeah, that's what I want. I wanted you to say that. All right, so that means we're going number 1 here, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. We good, right? All right. So what's outside the box, I'm going to put it in a dotted box here, the branch. I'm putting that one in a white dotted box. So now, let's first start with the green box. This is what we call the parent. This is the parent, is the one, that one there. So what is the name of the thing in the green box? It's got 7 carbons. Remember I said, remember MEP BP HOND, or however you remember. Heptane. All right. Yeah, so the name of this one, it's called hept. Can you see what I wrote in white? That's saying 7. And then ANE. It's telling me single bonds. We good? Good. Now we go to the box that is the dotted one down here. It's a branch. How many carbons are there? 2 carbons. What is 2? I said what is 2? I said what is 2? I didn't say give me the name. What is the 2? Go back here. What is the name of this one here? That is the name. But which one tells you the number of carbon? I'm asking you, what is 7? Heptane, it's a name. Which part here? I gave you colors. I even mentioned it. I said I'm writing it in white and yellow. Hept means 7. Then when you finish the name, it can be heptane, heptine, heptine. Can you see? 7 single bonds, 7 double bond, 7 triple bond. You see, because I want you to be able to to know the number first, then you know how to finish the name. So eth or eth or eth is for the 2. Am I right? 2 carbons. Am I right? But because it's a branch, it must end up with which 2 letters here at the end? YL. Yes, it will be YL. There we go. But now, the branch, we need to give its location. Which carbon is it attached to? It's attached to which carbon? Yes. We separate. So this is the address, 3 dash. We separate the letters and the number with an hyphen or a dash. You got it? All right. So when you give the name, you'll start with the branches, alphabetical order. You start with the branches, alphabetical order. There is only this branch here. So what I'm going to do, I'm just going to shift the name, put it down, and then you finish up with the parent name. I'm going to shift it and just attach it there. Can you see what happened? This is what we have. I brought this down, brought this one down, brought that down. We were here, down, down. Can you see? Branches, the parent name. And it is one word. How many words here? Ethyl heptane. One word. No spaces in between. I think you got that, right? All right. I'm going to give another.